Thank you, Cheryl, for the introduction. It's really a pleasure to be over here. I would like to start with a small introduction where I come from. So I'm from Wageningen University and Research, but it is important to emphasize that we have two entities. So it's Wageningen University, and that is mainly the fundamental research funded by the government, and it is Wageningen Research, that's more the applied research, and that's contract research. So I'm from Wageningen Research. So I'm based at Randwijk. It's an experimental station close to Wageningen. We have a section for plant pathology, entomology, plant breeding, post-harvest technology, and also economics. And we are focusing on palm, stone, and soft fruits. We do a lot with spray application technologies, because if you want to protect your crops, in most cases you are going to spray. We work with organic and integrated fruit growers. The number of organic fruit growers in the Netherlands is small. I think it's about 5% of the fruit growers is organic in the Netherlands. They face a lot of constraints in controlling pests and diseases, so the number is not really increasing. And we're also working a lot on innovative systems. So I have a picture of our station. It's about 50 hectares of palm fruit, 25 hectares is rented to a commercial farmer, and we can use 25 hectares of apples and pears for our experiments. So a few photos of our innovations. So this is a multiple row sprayer. We always work together with the industries. So in this case, we work together with a sprayer manufacturer. And I think we developed this already 15 years ago, because most of the growers want to have a 3-rower sprayer so they can spray 1 hectare in less than 20 minutes instead of taking an hour or so. With this type of sprays, you can also improve deposition and reduce spray drift. This one is about efficient water use, because in the Netherlands we also have problems with water supplies. And what we did is we were looking for an efficient use of water together with regulated water stress. And if you regulate water stress, you can also regulate tree growth and production. And it turned out that we can use water in a very efficient way by using water stress and still have productions of, let's say, 50 tons of apples per hectare or 60 to 70 tons of pears. So that could be of your interest as well. So this one is a kind of a greenhouse with a retractable roof. We can close the roof within 2 minutes, and we do this in case of a rain event. And if we close the roof, then we do not have problems with, let's say, fruit tree canker or scab, apple or pear scab. Because we have an issue in the Netherlands with pesticides, and what we have to manage is to become less dependent on pesticides. It is an invention or something new, but you always have benefits and constraints. So when we close the roof, there will be a dry environment, and then we will have bigger problems with powder mildew or insects. So we can control scab, fruit tree canker, but there will be more powdery mildew. So we are also working on precision orchard sprayers. In this case, we work together also with industries. Providers of sensors, so we can detect leaves and fruits. And we also have newer types of nozzles, so the PWM. So in that case, we detect a fruit or a leaf, and then we can also apply variable rate applications. In that case, we can reduce spray drift and reduce also dose. And the latest inventions are about robotization, so robot picking, because labor is really a constraint in the Netherlands. We also have a number of storage facilities at Randwijk, and we're focusing also on early detection of storage disorders or diseases, and we try to measure volatiles in that case. But we also look for the storage potential of new apple and pear selections. Just a few photos how we grow apples and pears in the Netherlands. So we have about 2,000, 2,500 of apple trees on a hectare. Average height is 2 meters 25 to 50. Production about 50 tons of apples. Pears is also 2,000 trees per hectare, 60 to 70 tons per hectare. We changed from an apple-producing country to a pear-producing country. So we have 18,000 hectares of palm fruit, 12,000 hectares of pears, 6,000 hectares of apples. Apple growing is difficult because we have a lot of competition from Eastern Europe. Main variety is Elster, free variety, so a lot of competition as well. So we are focusing on club varieties. Pears, conference, 80% is conference, so it is a monoculture of conference, and that is causing problems nowadays because we have problems with pear scab, fruit tree canker, and so on. A few photos about our fruit harvest. We harvest in plastic or wooden bins. You see in red, please handle with care, because that is also key in harvest and preventing rots. So what we often observe is that there are a lot of pressures caused by the pickers. So nowadays the pickers have to wear gloves, and that really makes a difference. The way we store fruits, I think that's the same way you store your fruits in South Africa. It's always CA, ultra-low oxygen. We store our apples for 8 to 10 months, and we can easily store our pears up to 1 year. And most of the people in the storage facilities, packing houses, use 1 MCP on apples, and we have also experiments on pears. I think Wendy Schotmans will have more details about that in the next presentation. What we do, we store and then we grade, because we also observe that if we first grade and then store, we often face problems with Phytophthora. Most of our grading water is infested with Phytophthora, so that is really an issue. So you can only have your fruits for a very short period in the grading water, otherwise you will run into problems with the Phytophthora. So now I shift to the fruit decays and the fruit rots. Well, I always discriminate between the wound infections, so the botrytis and the penicillium and the mononelia. So botrytis and mononelia can affect fruits in the orchard, but also often a post-harvest problem. We have our orchard infections, so that is mainly apple scab, pear scab, neonectia, European fruit tree canker, and Phytophthora. Staphydium is also an issue. I think you have some issues with Staphydium as an emerging disease in South Africa. And then, of course, we have our, what I call the real storage rots. They are often latent orchard infections. So that's the Neofabrea Growsporium, the bullseye rot. And I have here Cadophora, but that is really a disease that we encounter in our storage facilities. And of course, Colletotricum can also be a burden. So what parameters influence fruit rot? Of course, the climatic conditions, shortly before doing harvest. We all know if there is a lot of rain during harvest, then you will face problems with, for instance, Neofabrea or Phytophthora, always. But it is also related to inoculant pressure in the orchard. So what we have found is that, let's say, Neofabrea is present in every apple and pear orchard in the Netherlands. However, our main cultivars, so Elster and Conference, are not very susceptible. However, if we introduce a new variety and that is susceptible to Neofabrea, then we will have a problem. For instance, if we were able to plant Pink Lady, then for sure we will have a lot of problems with Neofabrea. So it also depends on your cultivar and variety. Of course, the storage period and the other issues I mentioned over here. A few photos of the main or most important post-harvest diseases. So the botrytis and fusarium. In most cases, botrytis and penicillium are not a problem in the Netherlands. Maybe because we have a lot to do with proper sanitation, careful picking, but sometimes we have problems with botrytis as a stem end rot, because sometimes when we are going to harvest, we have strong winds, and then the fruits will shake a little bit, and then you have the small cracks at the stem end, and then we will run in problems as well. Fusarium is an incident. It can be very severe, and as I already mentioned, Neofabrea is present, but we have some susceptible varieties, for instance, Pinova. If you grow Pinova, you will have a problem with Neofabrea. So penicillium sometimes a problem. Fibrorhizotonia is a typical problem for us on Elsta and Conference, but it only pops up maybe every 5 to 8 years because it is caused by a fungus that also decomposes organic material in the orchard, and it depends on the balance of the microorganisms who is most prominent. This is our main problem, cytod of pears, so it's Cadophora lutea olivacea. It popped up, I think, 10 years ago, but at that time, most of the growers and the people from the packing houses kept their mouth shut, because, well, when you see a problem like this and 80% of your fruits are affected, then no one wants to talk. No one wants to talk. But eventually we know, and it turned out that this disease pops up 6 to 8 months after storage. So most of our top growers, they had the problems because they store the fruits for a very long period. And they do everything that is possible for long storage. But this fungus just overgrows a fruit, and it's waiting in storage. And then after 8 months, boom, it goes. But now we know we can control it very effectively with a drench of pyrimethamine, and problem is solved. The question is, what's going to happen the moment we will lose pyrimethamine? Then we have a problem again. So this shows that drenching is more effective than orchard spraying. So we sprayed also with pyrimethamine in the orchard. But drenching is far more effective than spraying. However, it has only one active component, the pembotec, that's pyrimethamine. So you cannot control the fusarium or the Neonectaria candida. So we can control Cadophora, but still we have some other issues. So I also asked Dr. Lennox about problems that you face in South Africa. So you have problems with cosmetic molds, for instance, caused by Alternaria or Cladosporium. Of course, it's the limited post-harvest tools, so you also rely on fungicides. We also rely on fungicides. And of course, the reliance on fluoxetine, and that's one that might be phased out in the future. And of course, you face the problems that we have with the numbers of active ingredients. That is often a marketing issue, because it already started 15 years ago with Aldi, Lidl, and they said, well, maximum number of residues should be 5, maybe 100% of the summarized MRL. But we also know that maybe starting from 2030, supermarkets like Albert Heijn, Aldi and Lidl again, maybe they are going to put pressure on only 3 actives. And how are you going to perform an adequate strategy in controlling pests and diseases with only 3 actives? So you will run into problems with resistance management. And that's something we have to discuss with the industry, the retailers and the markets. You want good fruits, then you have to realize you need a proper way of controlling pests and diseases. So your most common storage diseases are caused by penicillium, botrytis, Neofabrea, Staphylium, fusarium. But you rely on only 2 actives, fluoxetine and pyrimethamine, as a post-harvest application, and what is going to happen when you are going to lose fluoridixonil. So this is what we are currently using in the UN in the Netherlands. So in red are the actives that are with a low efficacy, in yellow with a moderate efficacy, and green with a good efficacy. So as an orchard application, we completely rely on Captan. So that is our most used preventive fungicide. And we need that one to control Neonectria and Venturia apple and pear scab. Cyperodinyl and fluoxonil, so the switch, we use a lot to control also the brown spot of pears. Could be geoxyfluoxonil solo, and we use also the boscalid and the pyraclostrobin. But what you also see is that we also rely a lot on the fluoridixonil. So it's not only South Africa, we also do. And we use the pyrimethanil as Scala in the orchard, or Pembutec as a post-harvest application. So a little bit about the renewal of pesticides or active substances in the EU. So what the applicant, so the manufacturer, has to do, they have to apply for a renewal 3 years before ending of the expiry date. In this case, Syngenta has to do this for fluoridixonil. And they have to supply a renewal dossier. And those are the updated information about the substance itself, but also new information about environmental fate and behavior, ecotoxology, and so on. And then there will be a peer review by the EFSA. So the EFSA has the review, and then there will be a decision by SCOPAV. So we have 3 steps, and then the SCOPA decides renewal, or maybe renew with restrictions, or do not renew. So in the past years, we had, let's say, an issue with Captan. So Captan has been, let's say, reviewed, and fluoridixonil and cyperodinyl will be reviewed, are currently under review. Tebuconazole will also have an issue, most likely in 26, and maybe sulfur. But sulfur is considered as a green product because it's used by the organic growers, but it also has side effects. But if sulfur will be phased out, that will be the end of organic growers in Europe, all over Europe. So I think they will not phase out sulfur. So fluoridixonil is under the EFSA peer review. So Syngenta had put the information in the dossier. And now, let's say, the difficulty is there is a problem with fluoridixonil as an endocrine disruptor. And that's most likely the reason why there will be a non-renewal. So most likely 2026 is the last year in Europe to apply fluoridixonil. So they also had a look at the Captan. And for the Captan, it's a little bit different because now there are specific conditions to mitigate environmental and health risk. So that means we will have another label for Captan, but we are still able to use the Captan. However, it is a difficult label because it states you have to reduce the dosage, the dose, by 60%. So you can only use 40% of the recommended dose. And the other thing is, that's over here, you have to use a precision sprayer. but most of the growers do not have precision sprayers. So we have a new label, but very difficult for the growers to apply. So what are alternatives or what are options? So Kapton is difficult, but still they could use the diethionone or sulfur, maybe bicarbonates, but bicarbonates are a little bit difficult because you have to use those the moment spores are germinating. So scab spores can be germinating at night, so 1 o'clock in the evening or at night, and then as a grower you have to go out to spray your carbonate. For fluidixanil, maybe boscalid and perclostrobin can be an option. Pyrimethanil, that's pre-harvest or post-harvest, the 1-MCP. But 1-MCP only slows down the maturation of a fruit. It does not have a direct effect on the fungal disease itself. However, what we also notice is that if you use 1-MCP, also stalks or stems remain green. And you have an issue with molds on the stalks or the stems. So maybe 1-MCP could help you in that respect. So tebuconazole, there is a new product, I think it's Bayer, and that could also have an effect on Alternaria, so it could also replace the difenoconazole. For the ciperonil, we could use the pyrimethanil as well. So are the new products, are the new actives? So I asked around at Bayer, BASF, Syngenta, and they are working on the SDHI fungicides, but it is not very likely they will be available in the near future. So what we have, and we are going to lose some. So we have to look for new alternatives or strategies, because the companies are looking for green products. Adama is looking, for instance, for a bicarbonate, but we know difficult to apply. A lot of companies are going into the chitosan or other products, the bacillus, for instance, but those products are not as effective as a chemical active. So they can be active maybe they have an efficacy of 50, 60, 70%. And that's not good enough to control post-harvest diseases. So I think we in Europe are going to rely on pyrimethanil. There have been a lot of experiments in Belgium, Netherlands, and in Germany. We also observe that it is not as that effective as fluidixanil, for instance, against botrytis, but then you have to look for a strategy. So if you know a product is effective for, let's say, 70 or 80%, then you need something additional. So in the Netherlands, we can only use Pemotec or the pyrimethanil as a drench. And in Belgium, they often use, and in Germany, they use it as a fumigant. So the question is, do we also have sustainable approaches to control post-harvest diseases? Well, of course, the control atmosphere has an effect. And I think 1-MCP is really, really helpful in controlling a number of diseases together with pyrimethanil. Sometimes people ask, well, what about irradiation with UVC? But it's really difficult and complex, and the efficacy of UVC is not very high. So it's a kind of a superficial sanitation, but you also have to imagine or to realize that UVC light cannot penetrate the peel of a fruit. So the moment you have a latent infection, you cannot use UVC. So what about natural sources of resistance? It also has to do with breeding. So at the moment, most breeders are looking for, let's say, quality and production, but it should include resistance against the main diseases. So most of them are focused on scab, but it should also include other diseases. Biological control, maybe yes, maybe no, but I'm a little bit skeptical about this because Biological control is mainly focusing on root pathogens. And it is really complicated. So maybe you could do some dipping with one of the bacterial options. But to my opinion, I think we have to look into the direction of new actives together with a strategy. We also worked on grading systems, because there are a lot of pathogens present in the grading water. So we also developed a system that is able to purify grading water with ozone, and then we are able to take out, let's say, more than 90% of all the spores and so on of the pathogens from the grading water. So I think that this is also something to discuss, because I know we are relying on actives, but it should be a strategy. So what we need is a good understanding of the infection biology of our pathogens, and it should start in the orchard. Control starts in the orchard, because if you are able to control your disease in the orchard, you do not have a post-harvest problem. So it will be sanitation. Maybe in a strategy you can use a BCA. Breeding should be involved, and I think we need a lot of discussion between people who are specialists in storage conditions, pathologists and molecular biologists. And that's the reason why I like to have meetings like this, because then we are all together and then we can look for a systems intervention approach. Thank you.